Let us have a look at another problem where we are trying to find uh, the real root of the equation, okay, um, by Regula-Falsi method. Okay, so let us start solving this. So this is the equation where you got to find the real root up to 3 decimal places. Okay, so as here it is given that the root lies between there is a 2 and 2.5. Okay, so as the first process, your function which is f of x, the equation which is f of x, which is x cubed minus 2x minus 5, right? So to find that, uh, first we have to find the by substituting. Uh, uh, Let us keep this as the first root, which is a, and this is the second root, which is b. So f of a, okay, which is f of 2, okay. So as we find this 2 cube minus 2 into 2 minus 5, which gives us minus 1 less than 0. So as you see, this is negative sign, okay, and 5.25, let us say that, okay. So that is 2.5 whole cube minus 2 into 2.5 minus 5, so which is 5.625, so which is greater than 0. This is positive. So since f of a and f of b, okay, um, are of the opposite sign, the given equation f of x is equal to 0 does have the root which is m, suppose, okay, between a and b, okay. So the formula for the first order approximation of the root, which is x1, is a minus of b minus a divided by f of b minus f of a, and this is multiplied into f of a. Okay, so let us substitute this. See this, the first approximation here quickly. So let us substitute it. So here the first approximation x1, a which is 2 minus b minus a which is 2.5 minus 2 divided by f of b minus f of a, which is uh, 5.625 plus 1, okay, multiplied into minus 1. So which would results to 2.07547. Now, what you got this? Let us check the sign of this by substituting here in the given equation. F of x is x cube minus 2x minus 5, that is f of x1, or f of 2.07547. Okay, so please calculate this and tell me the sign of this. Okay, so while solving this, so we get this as negative of 0.210695. So which is less than 0. So uh, now as you see, it is getting closer and closer. Uh, this is 2.47 and this is 2.5. This is A and this is B now. Okay, negative and this is positive. Fine. So these are the new roots here. So we get the second approximation, keeping this as A and this as B. So as you can see here, B is constant over here. Okay, so the next approximation is this. So 2.075, which is A, minus 2.5 minus 2.07547, right, divided by 5.625 plus 0.210696, right, multiplied into minus 0, we got this result, uh, 069, right? So calculate this. Yeah, you get the second approximation here. You're getting the roots closer and closer. Okay, so um, so we got that as plus 0.2.0908. So uh, this is your x2. What you're supposed to do, you got to substitute in this here and get f of 2.0908. Please calculate this quickly. Yeah. So this big is minus 0.404,178. Now this is less than 0, right? So as you can see, this is negative. This is again 2.5, which is constant. So 2.5, which is positive. So this is your new A and this is B. So let us get x3 here. Please notice the values which you're getting here. I mean, this is 75, 2.075. This is 090. Let us see what you get. So as we got this as negative, right? So we get x3. So let us x3. We got that new root as 2.0908 minus this is 2.5 minus 2.0908 divided by 5.625 plus 0.04 178, okay, multiplied into uh, minus 0.04178, okay, so which is equal to 2.0938. Okay, so as you can see uh, here, the previous was this. Okay, now the new root which you got this, right? So as you can see here, we are trying to get closer and closer, right? So let us see whether when I substitute this root 2.0938, will it be negative, right? So for the function which is this, okay, for the function which is this, okay, so let us substitute it. Yeah. So this will be 0.838, less than 0. So as you can see here, again this is negative for 2.0938, and so this is negative, this is positive. So let us find x4. Okay, so this is 2.0938 minus 2.5 minus 2.0938 divided by 5.625 plus 0.00838. Okay, and this multiplied into this value. This is negative of 0.00838. Okay, so which results to 2.0944. So as you can see here, and this, okay, so we are getting 2.0944. So ultimately, up to 3 decimal places is required, which is m is the root, which lies between uh, these, so which is 2.094. So this is your root up to 3 decimal places. You can stop the iteration here. Now we'll do the same problem, but now I'll be using another method, which is Newton-Raphson's method. Okay, and our Newton-Raphson's method to find the approximate root here for the function which is f of x as x cubed minus 3x minus 5. And here, which is nearing to the root is given, which is x is equal to. So here your x naught which is given, or the first root which is given to you. Okay, so keeping this in mind, okay, so first thing, this is f of x is equal to x cubed minus 3x minus 5. So here you got to differentiate this, find the f dash of x, which is 3 uh, x square minus 3, or we can write this 3 multiplied x square minus 1. Okay, so the first, the general form to find the uh, roots, okay, so xk plus 1, or the order which you are going to find, xk minus f of xk divided by f dash xk. Okay, so we can write this in general form as xk uh, minus x cube k minus 3 xk minus 5 divided by um, 3 times of xk square minus 1, or we can simplify this as 2x cube k minus plus 5 divided by um, 3 times xk square minus 1. Okay, this is for a k 0, 1, 2, 3, and so on. Okay, let us do some approximation. um, okay, and stop the approximation where we get in the previous problem which we have seen how the decimals get nearer and nearer, so we can stop the iteration. So for k is equal to 0, so your x1 will be 2x cube x naught plus 5 divided by 3 into x naught square minus 1. So what is your x naught? X naught here is 2. So substitute it. So I'll substitute it quickly. This is 3 my 1. So this is 21 by 9, which is 2.333 and so on. Okay, we'll do the next approximation. Okay, this is what is approximation. Okay, approximate root. So please calculate this quickly. On the numerator, you get 30.406,318. Okay, and on the denominator, you get 13.332866. Okay, so this is 2.28055 x cube. As you can see here, there is a lot of variation with this. Here corresponding to 0.28.055, right? So this would be 2.27092. Okay, so you can see there is a 0.1 decimal change here. Let us move on further. I'm substituting and getting all the values. You can cross check it. 2.2709. Oh, sorry, 90. Sorry, this is 902. Okay, 902. So as you can see here, almost the same. So you can stop this iteration. So the root will be m, which is 2.27902. This is the root. Okay, approximate root for the equation x cube minus 3x minus 5. Let's solve this problem. Okay, so as you can see here, this is a Python code for the given problem. Here's the problem. Here uh, you have the Python code here. Okay, the problem which we have done earlier, right? Fine.